Nowadays, computer invaded every walk of human life, like trade, industry, entertainment, education, and etc. Computers dominate our lives more than any machine invented by man up until now.
Computers are all around us. From laptop computers to smartphones to smartwatches, they're changing the way that we live our lives.
Most of us think that a computer is a machine that can do arithmetic very fast, but it is much more than that. It is a device that can choose, copy, compare, and perform many other operations that are done by men. A man instructs a computer what he wants the computer to perform. A computer is a machine that performs a specific task to what the end user desires for it to do. A computer can perform specific tasks that is impossible for human minds. It can calculate numbers in seconds, it can hold large data, and it can communicate to someone that is miles away, and etc.
What exactly is a computer? A computer is an electronic device that manipulates information or data. The computer sees data as ones and zeros, but it knows how to combine them into much more complex things, such as a photo, movie, website, game, and much more.
Data is a collection of unprocessed items and information that has been translated into a form that is efficient for movement or processing. Raw data is a term used to describe data in its most basic digital format. So, what is information? Information is a group of data that collectively carries logical meaning. Information conveys meaning and it is very useful to people. So, input devices is a piece of equipment used to provide data and control signals to an information system. It sends data to a computer, allowing you to interact with it. devices is any peripheral that receives data from a computer, usually for display, projection, and physical reproduction.
Oh, okay. But then what are these devices you talk of? I don't see any output devices to this computer. That's one. That's a monitor, Tiri. How can that be an output device? Think, Miri. Oh, I get it. It displays the information after it is processed, and therefore it is an output device. Exactly. Well then, devices like the speakers or the printer are output devices as well? Yes, because they provide the user with the output after processing the information input by him. Speakers create sound. Printers can print out processed data. And monitors show the users the output in real time.
System unit. It houses the primary devices that performs operations and produces results for complex calculations. So, storage devices is any type of computing hardware that is used for storing, porting, or extracting data files and objects that is found in a computer.
Different types of storage devices such as floppy drives, CD drives, tapes, etc. The earliest computer storage device was actually punch card made of paper. Now we have storage devices which are either magnetic, optical or flash memory devices. Let's look at each one of them. Magnetic storage devices include hard disk and floppy disk. Hard disks are typically installed inside the computer, though portable hard disks are also available. Inside a hard disk, there is a spindle which holds one or more rotating disks called platters. These disks are coated with magnetic material. These disks have a magnetic head which is used to read or write data on the disk. Floppy disks were used to transfer data between computers. The computers have floppy drives into which the floppy was inserted. They used to come in 5/1/4 inch or 3.5 inch size. As their data capacity was very less, pen drives have now become more popular.
So, communication device is any type of hardware capable of transmitting data, information, instructions between a receiving device and a sending device.
Okay, first we'll look at a simple hub. A hub's job is to connect devices in your network together. Let's see how it works. Let's say host A sends some data to host C. When a hub receives the data, it repeats it out of every port except the receiving one. Host C gets the data, but so does host B and D, so they simply discard it. The hub has many downfalls. It wastes bandwidth, as we've seen when host B and D receives unwanted data. A hub uses something called half duplex, which means it can't send and receive data at the same time without causing a data collision. This would cause your data to become corrupt and need to be sent again. So in overview, a hub is a layer 1 device, meaning it has no knowledge of addresses. All it does is repeat any data it receives. They have one collision domain and uses half duplex. This means it can't receive data and receive data at the same time. They waste bandwidth by sending data to hosts unnecessarily. It has security risks because all the hosts receive everyone's data. A malicious user could steal this. Hubs are old technology. They have now been replaced by switches, which we will take a look at shortly. Bridges were introduced to combat some of the shortcomings of hubs. They're used to segment networks into smaller sections. When data reaches the bridge, it decides whether or not to forward the data. It does this by looking at the destination and source MAC address. Every time the bridge receives data, it learns the source address, looks at the destination address, and decides to send the data or discard the data. We will look at this process in more depth when we discuss switches next, as it uses a similar process. So, a bridge is a layer 2 device. This means it can understand and learn MAC addresses. It segments LANs into smaller sections. It has two collision domains. This means data can be sent or received on each section of the network at the same time. A bridge usually has two ports. Bridges are not used anymore. They have also been replaced by switches. Now let's take a look at switches. Think of a switch as a hub and bridge rolled into one. It connects the devices together, but it can also learn which ports connect to which hosts. Let's see how this works. A switch has something called a MAC address table. This table will list each MAC address and which port is connected to. In this example, host A will send some data to host C. The switch receives the data, but as you can see, the MAC address table is empty. The switch in this case will forward the data out of each port just like a hub. Unlike a hub, the switch now learns host A's MAC address can be reached on port 1. When host C sends data back to host A, the switch knows exactly where to send the data. Now if you notice, the switch has learned that host C's MAC address can be found on port 3. Using this process, very quickly a switch can learn how to reach each host connected to it. Let's review. A switch is a layer 2 device. Like the bridge, it can learn MAC addresses, which are known as layer 2 addresses. A switch can use full duplex, meaning it can send and receive data at the same time. This means each port has its own collision domain. This is a huge improvement over a hub. Because it can learn MAC addresses, a switch saves huge amounts of bandwidth. And now because only the destination host is receiving the data, other hosts can't steal it. Routers. You can think of routers as the doorway out of your internal network and into the outside world. To understand what routers do, let's take a familiar example. Let's say this is your home computer, this is your switch, and this is your router. Now just on a side note, usually a home router has the switch built in, but in an enterprise network, they're separate devices. So on the other side of the router, you have the internet. Let's say you send an email or visit a website. Your computer will send data to the router using its IP address. The router will then forward the traffic out of your home network and into the wonderful world of the internet. When data comes back,